Good evening, all. Yeah, good evening. Please wait for 5 more minutes. Let's others to join. We'll start the session in 5 minutes. Thank you. Okay. Good evening, all. Let me start the session. I'll give a brief introduction about me, those who have joined today new, and in between others will join. Okay. So I am Saravanan, PhD scholar and Prime Minister Research Fellow of Department of Civil Engineering in NIT Tiruchirappalli. So as a part of PMRF deliverables, I'm taking the problem solving session of the NPTEL course, Air Pollution and Control, and this is my third course. Earlier I have taken Integrated Solid Waste Management, Plastic Waste Management, and this semester I am taking this course, Air Pollution and Control. So every week, Tuesday, 6 to 8, the problem solving session will go, and the first 1 hour will be the same lecture material what Sir has taught in the YouTube video, the same I am going to teach. And the other 1 hour, we are going to solve the old assignment problems of last semesters and all. So we are in the 10th week of this course. And in the first 10 weeks, we have discussed about what is air pollution, what are their impacts on the human health, vegetation, animals, buildings, and all. And the second week, we have discussed about different sources of air pollution, like primary air pollutants and secondary air pollutant. And in the third week, we have discussed about the meteorological parameter that affects the atmospheric stability, because where the stability is required, whenever the atmosphere is unstable, then only the dispersion of pollutants are happening. And that's based on lapse rate and plume behavior, that and all we have discussed. That's why we are designing the higher uh, chimneys to emit the pollution at a higher elevation, so that the unstable condition will prevail and the ground level concentration will be reduced. And we have solved some of the models like Gaussian plume model, air quality modeling for point source, line source, and area source. Some problems also we have discussed. And in the fifth week, we have discussed about the emission inventories, like how to assess the emission in transportation sectors, industrial sectors, agricultural sectors, residential and commercial sectors. And in the sixth week, we have discussed about the application of remote sensing in the emission inventories. And seventh week is fully on indoor air pollutants, because there is a myth, as we have discussed earlier. The indoor air quality will be good, but most of the time, 90% of our time will be indoors, and there is a 20 times higher pollutants are there in indoor compared to the outdoor environment. So that's why um, indoor air quality plays a major role in the human health and environment, and that also we have discussed, and some of the treatment technologies. And the eighth week, we have discussed about global and regional environmental issues of air pollution, like ozone depletion, climate change, global warming, acid rain, and all. And last week, we have discussed the air pollution control devices for particulate matter removal. What are the six things we have discussed? One is gravity settler, cyclone separator, fabric filters, wet scrubbers, and the other one is electrostatic precipitator. In the same, for these are all for particulate matters. And for volatile organic compounds, we have discussed some of the other techniques like absorption, condensation, oxidation. These are all the techniques we have discussed, and biofiltration. You got it? So this week, we are going to discuss about the problems related to the same control equipment, control devices, and their design. Some of the problems we are going to discuss, and I am going to share with you a formula sheet where I have compiled all the formulas for this pollution control devices, air pollution control devices. So in a three sheet that you can keep with you for your exam preparations. And the older problem also, I will share you the sheets, same like sheets like this. Okay, so first two lectures will be on the problems. Later, the three lectures will be on national and international policies on air pollution, acts, rules, and regulation we are going to discuss. Okay, that's what's today's agenda. Yeah. So we will move on with the problems for today. So we all know about the air pollution control equipments. So this is what the formula sheet I am talking about. So have this formula sheet. I'll share with you in the PDF format. Hope it is visible to all. Like this is the formula related to settling chamber, this is for the cyclone separator, this is for the fabric filters, and this is for the electrostatic precipitator, and this is for the wet scrubber. If you have this page with all the notations, you can solve all the problems. In the second page, you can see this is for the absorption, and oxidation, and one sheet specifically for condensation. We have skipped a lot of these formulas in the last lecture that we are going to see today in the problems. Okay, you got it? So this three sheets I will share with you, the formula sheets. Okay, so just I will keep in one side and I will show the problems in the half of the screen. Yeah. Okay, let's move on to the lecture. Sorry, one second. I'm sorry. Please wait a second. Hope it is visible now. And sorry, you want to ask something? You are unmuted. You can ask Murmusa. today we are going to see about the practice examples for particulate matter emission control devices. So what we have seen, one is settling chambers, fabric filters, electrostatic precipitators. Um, yes, you can see cyclone separator and the wet scrubbers. Okay, yeah. First, the problem. Just read the problem. You will easily come to know about the unit. So based on the unit itself, you can solve majority of the problems. And don't forget to change the units all in a single form. If it is a kg, you have to make everything in a kg. Or if it is in a pound, you have to make everything in pound. If it is in Celsius and Fahrenheit, you have to make it accordingly. And some will be in meter per second, some will be in miles. That also you have to check. Okay, some will be in hours, some will be in second or minute. That cancellation, unit cancellation, you please be keen on. So all the problems will be based on the unit conversion only. Just I am reading the first problem. Just convert with me. Calculate. Sir, can you mute? Okay. Sorry. So calculate the. This is you can read the question and you can identify which treatment technology it is. Calculate the minimum size of the particle that will be removed with 100% efficiency from the gravity settling chamber. Okay, that's what the question they have asked. Yeah. So gravity settling chamber is the treatment technology, and we all know there is a gravity chamber. So this will come and air will go out, and this velocity of the air and settling velocity of the air should be equal so that the particles will settle before leaving the chamber. That's what the principle behind gravity settling chamber. You all know. So they are asking what is the minimum size or minimum diameter of the particle that will be removed for the given condition. What's the given condition? The horizontal velocity of the air that is given v 1.2 meter per second at the temperature of 75 degree, and the particle specific gravity is 1.5. That is the particle that we are going to remove in the settling chamber, and the chamber length is 10 and height is 1.5. So why we need height? The settling is based on the height. If the height is less, more settling will happen. That's why tube settlers we will use for water treatment. So at 75 degree viscosity, at 75 degree Celsius, viscosity of the air is 2.1 into 10 power minus 5 kg per meter second. You all know about viscosity, right? So air's viscosity they have given. So what's the formula to find minimum size of the particle? We have the formula dia. So how we arrived at the formula? I will show you the formula sheet again. So here you can see, just we have made the settling velocity and the horizontal flow velocity equal. What is the velocity? Distance by time. So distance is for horizontal velocity, distance is L and the time is T. And for settling velocity, the distance is height and the time is T. So both T, if you equal and if you make equal, H by V is equal to L by V. This is the formula, and we have come up with this formula. For settling velocity, we have given Stokes law will be applied, and we got this diameter formula and the efficiency formula. So diameter of a particle equal to 118 in 18 into VH mu by LG rho p minus rho power 1 by 2 or root of you can say. So all is known, like V is the velocity, horizontal velocity, we all know 1.2 given. Height of the chamber we know. Mu, this viscosity we know. Length of the chamber we know. Gravity, acceleration due to gravity 9.81 we know. And rho p and rho are the things. So density of the particle they have given 1500 where is the specific gravity they have given. So we all know the density will be 1500. Yes. So the density of the air you can take as 1 or you can take as 0. So 1500 minus 1 or 1500 minus 0 also. Density of the air will be 0 or 1.2 kg per meter cube. That is negligible only. So that if you all substitute here, you will get the answer is D equal to, why it's in meter, so all the units are in meter per second meter, so you will get in meter 6.79 10 power minus 5 meter. So if you convert to mm or micrometer, 67.9 micrometer is the dia of the particle that will be fully settled. That is 100% efficiency. Okay, if 67.9 micrometer is settling, then obviously 100 micrometer will settle, 1 mm will settle, 1000 mm particles will settle. So this is the concept. This is the minimum diameter of the particle that can settle. So more than this dia, everything will settle. Okay, you got the first example. If any doubt, please unmute and ask, or you can post it in the chat box. Or you can stop me anytime. Okay, I'll move on to the second question. Estimate the collection efficiency of 75 micrometer dia particle that's the dia of the particle they have given. In a simple settling chamber, length is given, sorry, width is given, height is given, and the length is given. So it's a square chamber. Okay, like this, there is a chamber. Okay, assume the gas velocity, that is V they have given. Okay, 5 feet. So here you can see everything is in feet. Don't forget to convert everything in feet. So the dia of the particle is in meter. So convert that also in feet. Okay, that you have to take care every time. Meter to feet, miles, second to so here you can see the particle density is 120 pounds per feet cube. So here it's in feet cube only, but it is pounds. So kg you can't take anywhere. Everything should be in pound. And the gas time condition of a 68 degree Fahrenheit and 1 atmospheric pressure they have given. So what they are asking, collection efficiency. So there is a formula for efficiency, eta. The formula is 1 minus e power minus g rho p lw nc dp square by 18 mu q. So if the same if I apply for 67.9 in the earlier problem with all this condition, I will get the efficiency. What will be the efficiency? 100% it will come. Or if I take any diameter greater than this, I'll surely get 100% efficiency or more than that. So here they are asking what will be the efficiency of the collection for the given dia of the particle, that is 75 micrometer. So efficiency formula is this. What are the requirements? G is 9.81. Rho particles density they have given, right? 120 pounds per feet cube. That is also given. L length width of the chamber we know, and NC is the number of partition, because in the settling chamber, as I mentioned, if there are lots of partition, then there will be more settling, because the height, instead of 3 meter height, if I am putting a partition in between, height will become 1.5 meter, 1.5 meter. So if height is reduced, particle settlement will be more. So if there are two compartment, that NC you have to give us 2. But here they are saying single, a simple settling chamber with no compartments. So there is only one compartment. So NC will be 1. Okay. The dia of the particle they have given us 75 micrometer. So convert it to feet. So 75 micrometer I have converted to feet. That you have to square up, and 18 mu. Mu is the density of the air. Again you can take as viscosity of the air as 1, or you can take it as negligible 1 also you can take. Negligible, don't put at 0. Okay, negligible means 1 you can take. And Q will be the flow, that is in meter cube per second, the flow Q. So that is not given, right? The Q is not given here. Yeah. So we need Q. Flow rate, how to find? Flow rate will be meter cube per second. Here everything is feet, so feet cube per second. So how to find feet cube per second? We know the velocity, feet per second is given. Velocity is given 5, right? 5 feet per second is given. So if I multiply another 2 feet, it will come as feet cube. So what are the other 2 feet? It is flowing in this direction, right? So height and width I will take. So what is the height and width? 10 into 10. So the given velocity is 5, and the height and width is 10 into 10. So I will get 500 feet cube per second as the flow. So Q is known, flow rate is known. So all the parameters are given, right? So substitute and get the efficiency. So efficiency is 0.475 or 47.5 percentage by 100 you can take. So if I take 75 micron or 2.546 feet particle into 10 power minus 4, or 75 micrometer diameter particle, 47.5% of that particle will settle. Other 52 particles, 52% will go out along with the effluent gas. You got it? So that's the concept behind the settling chamber. So we are now moving into cyclone. Is there any doubt in the settling chamber? Only two formulas to find the dia of the particle with the given efficiency, I mean 100% efficiency, or they will give the particle dia and they will ask you to find the efficiency of the particle. Just remember the formula. I don't think sir will give the formula in the exam. If it is given, it's well and good, or else please remember the formula. It is, you can derive also easily the formulas. Okay, so I'm moving to the third question. A cyclone has an inlet width of 10 centimeter and 4 effective turns. So, you know the cyclone's settling chamber, it will be like this, right? There will be a hopper and there will be inlet and there will be outlet. So, air will come through this, it will go for some turns and particles will settle, air will move up. That's the cyclone separator. So cyclone separator having an inlet width. This is given 10 centimeter, and it's taking 4 effective turns. That is also given. The gas temperature coming in, gas temperature is 350 degree Kelvin, and the inlet velocity is 10. Inlet velocity they have given us 10, and the particle density is 1.5 gram per centimeter cube. That's the settling particles density. What is the cut diameter? They are asking for the cut diameter, D suffix C. That is the cut diameter. Particle size with the 50% efficiency is the cut diameter. D 50% also you can take. Okay. Yes. They are again given some data as viscosity of the air at this given temperature is this much. So they are asking about the cut dia. I have given in the formula sheet. You can take the cyclone separator. This is the formula. dP minimum if you want, it will be dia mu B by pi B nt rho P minus rho. That is minimum dia. That is 100% efficiency. They are asking cut diameter or 50% efficiency. What will be the dia of the particle that will be collected? So 50% efficiency, you have to divide it by 2. The whole inner part you have to divide by 2. So 1 by 2 of the same formula inside the root you can take. That is with 50% efficiency. You got it? Just remember this formula. So I have given the cut diameter formula directly here. 1 by 2 into the whole formula. What are the known things? It is known. Mu given. B is the width of the cyclone inlet duct. There is a duct, right? Through that only it came. This duct. The width is given as 10 centimeter. So all are in meters. You can convert this also in meter. And centimeter cube also you can convert to meter. Okay, so 0.1 meter. Then pi known, V is the velocity, inlet velocity. So 10 meter per second we know. Nt, number of turns, 4 turns it's taking. And rho P minus rho. Particles density they have given us 1.5 gram per centimeter cube. Convert to kg per meter cube. That is a standard SI unit. And the rho you can take as 1 or the given value also. Viscosity of the air you can take. Neglected or taken as 1. Okay, if you substitute, you will get the cut diameter. So the cut diameter will be 7.04 micrometer. You got it? If you have any doubt, you please post it in the chat box. Hope you understood this. Cut diameter in cyclone separators. Again, the other question in the cyclone separator, a cyclone has an inlet width, W is given, and the 4 effective turns, again the same. The gas temperature of this, the inlet velocity is this, particle diameter is given 8 micrometer. They are asking about the collection efficiency. So you can back calculate using the same formula. See? So cut diameter you can find, and the graph. Okay, I will go with the formula sheet now. So there is a graph. If collection efficiency for the cyclonic separator can be identified with this graph. So in this graph, you can see y-axis is collection efficiency of the cyclone separator. X-axis is the particle size ratio. Particle size ratio is dia by cut dia. That is the particle size ratio. So they given the particle size. We can find the cut dia by making it as 50%. Then get a ratio of that. And then you just go with this 1.5, and wherever the graph meets, go there. 50, 60, 70. 70 will be your collection efficiency. Got it? So I am finding the cut diameter. We know the same formula. Cut diameter is 7.04 micrometer. They given the dia as 8 micrometer particle. For 8 micrometer particle, for 7 micrometer particle is the cut diameter of 50%. The ratio is 1.14. So go with this graph. 1 is here, 1.5 is here. So 1.1 will be here, right? 1.1 is matching here at 50, 60. In between 50 and 60, it is 55 percentage is your collection efficiency in percentage. You got it? So that will be for cyclone separators efficiency calculation through the graph. So if they are asking this the sums and all, they will give the graph, don't worry. So it will be easy. Just remember, for cyclone separators, we need to find the diameter, that's given diameter, and the cut diameter. If you take the ratio and compare in the graph, if they given the graph itself, you can easily identify d by dc you did, right? And get the efficiency. For that d cut formula you have to know. Okay. Can I move to the 5th question? Okay. I hope you are understanding the concept and the formula. Are you with me, people?
Yes, sir.
Okay, thank you so much. I'll move on with the fifth problem. Here we are going with the fabric filter. First, we have seen about the settling chamber. Second is the cyclone separator. Now we are moving with the problems of fabric filters. Okay, so the fabric filter has 2000 meters square. You all know fabric filter how it works. There is a filter bags made up of cloths, any fabric material or glass wool. So air will be passed from in to out or out to in anyway. The pores will be there in cloth. Like if you take a kerchief and if you blow, the air will come out through the other end, but the particles will settle in this one end. So particle will settle here, pure air will come out. Okay, then these particles can be scrapped out or washed. So that's the principle of fabric filter. But the pore, how much big pores are there? That's the design principle. So that will be designed to find the number of fabric filters required. Okay, so they given the question. Fabric filter has a filter area of 2000 meter square and the threads totally they have given 15 meter cube per second of air carrying a dust of concentration. 15 meter cube of per second is the flow rate q they given. Okay, and the air carrying the dust concentration of the dust is 0.015 kg per meter cube is the dust concentration, and k1 and k2 are the constant they have given. If the filter must be cleaned when the pressure drop reaches to 3, because whenever the pores are getting full, if you can think about the air AC in your room, so AC, if you more dust are there, no cooling will come. Why? All the pores are filled with the dust, so no cooling is happening. Same in fabric filters, if all the pores are filled with the dust, then there won't be any cleaning. Pressure will get dropped. So if the pressure reaches 3 kilopascal, then what will be, when we have to start cleaning, right? So they are asking what is the period of cleaning, that we can find with the formula itself, because we have designed that. So we know the cleaning period. We can make the minimum pressure drop. So if it reaches 3 kilopascal, you have to clean. But when to clean? That period we are going to calculate. Okay. So I am going with the formula sheet. Yeah. So for fabric filters, these are all the formulas. It's based on the Darcy's equation, right? So they have given the overall pressure drop is equal to conditional residual pressure drop plus pressure drop due to dust cake. These are the two concepts. Thus we have discussed last week in the design of fabric filters. So total pressure drop will be your conditional residual pressure drop plus pressure drop due to dust cake. So that you can rewrite like this if x and the k are given, or you can rewrite like delta pt will be k1b, that is delta pr, and delta pcs k2ci v square t. So delta pr is k1b, delta pc will be k2ci v square t. So they given the overall pressure drop as 3 kilopascal, and K1, K2 they have given. Velocity of the air, that is the superficial gas flow velocity, that they have given. Ci we are going to find, and T. Ci, how to find Ci? Ci is the dust loading. That concentration also they have given, right? So we can easily find all the parameters. See, the pressure drop is given. We can find the formulas K1V plus K2 Ci V square T, because we don't have x and y, so this formula we can't use, this formula we can use. Substitute all the values. K1 is given, but please remember again, the unit should match. If all are in meters, everything should be in meters. Kilopascal means kilopascal, kg means kg. Think about mass, time, pressure, distance. So distance should be in meter, time should be in seconds, mass should be in kg, pressure should be in kilopascal. If all the four, and temperature if it is in Fahrenheit or degree Celsius or Kelvin, that all should be in same unit. Okay, yeah. If it is the empirical formula, they will mention temperature you have to substitute only in Kelvin, temperature you have to substitute only in Celsius. That will be mentioned in empirical formulas. But these are all conversion formulas. You can easily change any values. Okay. Now the T is the unknown. That's what they asked in the question. Filtration time or period of cleaning. Okay. So del PT is substitute as 3 kilopascal. Okay. So everything they have converted into Pascal. So 3000. And K1B, because K1 value is in that's also in kilopascal only. 25. They change it to 25,000 Pascal second. And V, how to find V? 0.75 meter per second. It's given in the question. Velocity, yeah, the dust concentration is 0.015, 15 meter per second is a flow rate. Filtration velocity you can find here. So 15 meter cube per second is given. If you know meter square, then you will get meter per second, right? So how to get meter square? The area, filter area is 2000 meter square. That also they have given in the question. So 2000, if you divide 15 by 2000, you will get 0.075 meter per second. That is your V. Again, here also same V. Say K2 you know. Concentration of the dust 0.015. That is also in kg per meter cube only. T you will get in what unit? Here all in seconds only, right? So T you will get in seconds. So 33,300 seconds, that you can anyway convert into minute or hour, whatever you want. So after 9 hour, 30 minutes or 26 minutes, you have to clean the filter bags. That's the question. That's the design concept. You got it? Yeah. So for filter bags, you have to go with the pressure drop. If it reaches the pressure drop of 3 kilopascal, then you have to clean. So total pressure drop will be based on residual pressure drop and Kx pressure drop, that dust Kx pressure drop. So that can be converted in this formula type. First one will be K1V, second one will be K2CI square T. So K1 and K2 are constant, that's given. Velocity can be found from flow rate by area, because V equal to Q by A or Q equal to AV, any formula you can take. This will be in meter cube per second. This will be in meter square. So you will get meter per second as velocity. Then time will be in seconds. That is your known. That is unknown, or you are going to find. Ca is the concentration of the pollutant or the dust. That is given 0.015 kg per second. Yeah. So I am moving on to the sixth question. Same filter bags question. If the process gas exhaust gas rate is given as low. So after a process, there is exhaust gas coming out. Exhaust gas, you know, from any industry, whatever the gas coming out, that is the exhaust gas. So that's coming in the rate of 4.72 into 10 power 6 centimeter per cube per second, or they have converted already to feet cube per minute. So check everywhere, if it is feet, make it as feet. Everywhere if it is a meter, make it as meter. And the filtration velocity is 4 centimeter per second. Okay. So A by C ratio, A by C means uh, this is a cloth ratio, total area by cloth area. That is the A by C ratio, 4 is to 1. What will be the cloth area? So, if you understand A, then you can easily get C. A by C, total area by cloth area ratio is 4 is to 1. So, 4 by 1. So, if you know A, the total area, then you can easily find the cloth area. How to find C? That is first question. Then, second question is calculate the number of bags required. So, if you know the total area, if you know one bag area, then you can easily identify how many bags. So, they have given bag dia and bag height. So, one bag area you can easily find, right? So, that you have to divide with the total area and you will get number of bags. So, how to go with A by C gross ratio? There is A by C gross ratio, A by C net ratio. So, A by C gross is total area by cloth area. A by C net means net area by cloth area. Okay. So here I am taking the total area. So A by C cross equal to, so I am just going with the formula sheet again for filter bags. Here you can see A by C cross equal to Q maximum by A total. So that is given as 4. So Q maximum is flow rate we know. So area total we know that we can find. Area total how to find? Because pi dl. It's a circular dia is given. It's like a floor mill bag. You all know for floor mill, right? Wheat, if you grind, there will be a bag out. There only will get the floor, wheat floor, right? Same like this is cylindrical cloth. Dia is given, length is given, so you can find the surface area because the filtration is happening on the surface of the bag. So surface area we need to find. The formula for surface area in the cylinder pi dl. So pi into d into everything was given already, so we know the a value. So fine. Now ABC is 4. They have given 4 centimeter cube per second per centimeter square. From the unit itself, we can know meter cube per second will be the Q. Centimeter square will be by A. So Q by A. That's the formula. Q max by A total. So Q max is given a 4.72 10 power 6 centimeter cube per second. Everything you can make it a centimeter. Area total we don't know. So that we can find with the cross multiplication, you will get the centimeter square or meter square. That's the required cloth area. Then number of bags they asked. So we know the total cloth area required 117.98 divided by one bag's area will be pi dl. So d and l of one bag is given in the question itself. A bag of dia and height. So the height will be your length 3.66 into pi into 0.23 meter. So you will get area of one bag, and 51 bags are required to filter the concentration of this much dust. You got it? Okay. I'm moving to the seventh question. Hope you are all with me. So seventh question is a baghouse filter. What is baghouse filter? If it is one filter bag, then it is a filter bag. If there is a lot of filter bag in a single compartment, then it is a baghouse. Okay. So if it's a baghouse filter, 20 compartments are there. Then 20 filter bags are there. If you see from top, it will be like 5 into 4 or 4 into 5 like that. It will be arranged fully. And it's like a series. All will be, sorry, parallel. Air will go in and air will come out. So 20 compartment, each compartment 360 bags per compartment. So think about how much bags will be there. If you see industrial scale filter bags, Venturi scrubbers, it will be very big. Don't think like a small bag. It will be like a big cloth bags. And each bag of diameter 11 meter and bag length of 30 meter. 11 each bag itself 11 meter. Then think about 360 bags and how much length of the compartment with the gas flow rate of this is the Q and the gross and net cloth ratio they are asking. So they are asking about A by C total or A by C cross and A by C net. This is the value. For that A by C, what is the value? Q by A. So if you put Q bags by A total, then you will get A by C gross. If you put Q bags by A net, then you will get A by C net. Okay. So I will show you the formula again here. So this is the value. A basic gross equal to gross air to cloth ratio, air to cloth ratio. And A basic net will be total air by net area. Okay, we'll go with the problem. So this is the formula for gross. Q max by total. Q max is given as meter cube per minute. They already given. So area total only we need. So one bag diameter, you know, pi dl is the same formula. If you put one bag, you can find into 360 bags into 20 compartments, you will get the total area in meter square. That I am talking about the surface area. Surface area only will filter the dust. It's all for particulate matter only, right? Think about the impact of particulate matter and how the industries and all the premises are working to remove this particulate matter what they have generated. You got it? So these are all important concept. So Q max, you know, total area you can, you know, you have calculated already, and if you divide, you will get gross air to cloth ratio. That is 0.161 meter per minute. Or if they are asking for the net area, then you have to think about how many compartments are in servicing or not in servicing. Means if 20 compartments are there, only 18 will work. 2 will be for backup while cleaning, or if anything repair happens, that 2 will be take part. So they are saying to calculate the net air to cloth ratio, the net fabric area is calculated by subtracting out the compartment which are not in filtering area. So they have mentioned in the question itself. Yeah. Assume that two compartments are out of service when calculating the net air to cloth ratio. So only 18 is in service, 2 are out of service or backup. So just subtract 20 minus 2, 18 into 360 into one bag's area, surface area, then you will get the total area. I mean net total area. If you divide with the Q max, you will get the A by C net. So think about the whole formula page. You will get all the formulas in this one page itself. I am now moving to the electrostatic precipitators. Yes. So hope you all learnt about now the problems, how to solve the designs of uh, settling gravity settlers, fabric filters, and cyclone separators. Okay. Now it's electrostatic precipitator. So for find they are asking find the collecting. You all know what is electrostatic precipitator. There will be some plates and there will be a rod to discharge the corona. Corona in the sense the charge. So air will be passed through this gaps between the plates. If there is any particle in the air, that will acquire negative charge from the wires because it's continuously passing the electricity. So the particle will get charged, negatively charged, and the plates will be connected with the positive charge. The line will be connected with the negative charge. The particle will move towards the plate and it will get attracted. The pure air is not conductor, it will go out. Okay, so this is the principle. We have the surface area. This is the area collecting. This is the area collecting. Backside of this another area is collecting. So they are asking find the collecting plate area and the number of plates to be used. So they ask number of plates and the plate area. Single stage electrostatic precipitator, they said. Handling a single stage, only one stage, and handling an average gas flow rate, the V of the gas, that's sorry, Q of gas that is entering into the electrostatic precipitator, 2.5 meter per cube per second. From a pyrovised coal-fired boiler, that's the industry. The collection efficiency I have given us 98%. So all the 100% particle moved will not be collected. Only 98% will be collected and 2% is coming out along with the effluent gas. Okay, this is the flow diagram. Drift velocity plays a major role in the electrostatic precipitator. So omega is the major factor, 12 centimeter per second. All the efficiency of your electrostatic precipitator is based on omega, drift velocity. So that's the formula I'm going to use now. So they are asking the plate area. So if you know the area, you will get the plate area, then number of plates you can identify. So eta is the efficiency. This is the Deutsch-Andresen equation that I have given in the equation formula sheet also. So efficiency equal to 1 minus e power minus omega a by q. What is pending here? Efficiency is 98% we know. Omega is given 12 centimeter per second. Q is known flow rate, that is a Q inlet gas Q. Then A you can easily find, right? So how? So Q is 2.5 meter cube per second. Omega is given, 98% is given. So 0.98, 1 minus e power minus 0.12 into A by 2.5. So subtract this, you come here, like then E will go with land. So land, if you take on both sides, E will go off and minus 0.2, 2.5 will come here, 0.2 will come down, and minus minus will get cancelled, and you will get the total area of the plates for getting 98% efficiency. So that's the required area, right? 81.5. And they given, or you can assume if they're not given the plate with the, and the, if you know, one times the general condition is width will be 1.5 to 1 times the height. So if I'm taking 4 meter wide plate, height will be 5.2 meter, that is 1.5 times, or sorry, uh, like what is equivalent, that's the height of the plate. So if I buy 4 meter cross 5.2 meter plate, then 4 numbers will be required. That's the concept. See, we know the total area is 81.5. One plate area will be 4 into 5 because I need the surface area. So with the height required to absorb the particles. So because charge will be here only, right? So I need to calculate the surface area. 4 into 5.2 will give you 20.8. If you divide it with the total area, I will get 4 number of plates. But 4 number of surfaces only required. So 3 plates are enough to get 4 surfaces. You got the principle? Because if you keep 2 plates parallelly, then only 2 surfaces will be there. If you keep 3 plates, 1, 2, 3, 4. 4 surfaces will play in 3 plates itself. Area will be more. If we plate 4 plates, then 1, 2, 3, 4, 5, 6. 6 surface will be acting for electrostatic precipitators, charged surfaces. So if I want 4 surfaces, 3 plates are enough, of size 4 into 5.2 meter. You got it? Yeah. So another question related to electrostatic precipitator. Find the collection efficiency of a horizontal flow single stage electrostatic precipitator. Okay, horizontal flow consists of 2 sections formed by plates 4 meter cross 5 meter. 2 sections. Okay. 4 cross 5, 6 meter. Of 20 centimeter center. Okay, distance they have given between the plates. Handling a gas flow rate Q they have given. Assume the migration velocity, that is omega. Omega is 12. So what they are asking now? The efficiency. Okay, what is the formula for efficiency? 1 minus e power minus omega a by q. Yeah, omega a by q. So this is the formula, right? So that's given in the formula sheet also. So what is the requirement? Q is there, W omega is there. So A you can easily find. Sorry, A is given, collection efficiency only they are asking. So what is the plate area? 4 meter. Another one is 6 meter. That's the plate area. So if you substitute the plate area, and why they are subtract multiplying with 2? Because plate area of each section will be this much 4 into 6. Then now for the two plates we will have two plate area. So 48 meter square will be your plate area. If you substitute everything, you will get the efficiency 99%. What is the second question they have asked? That's it. Okay, again there is a problem with the electrostatic precipitator. Find the migration velocity. They are asking about omega. For the existing electrostatic precipitator, in which the collection plate area A is given, flow rate. With the unit itself, you can find that. Meter cube per second is Q. Collection efficiency is given. So again, if you use the same formula, 1 minus e power minus omega q by A. Sorry, A by Q. Omega A by Q. You will get omega. Just take ln on both sides. 0.12 meter per second. Okay. Now another question related to electrostatic precipitator with corona power discharge. So there is another formula that I have given. Uh, Let me read the question first. Calculate the corona power for a corona power is the negative charge required to give to the rod that is hanging in between the plates. So for electrostatic precipitator, which is designed to treat 9,000 meter cube per minute, that is a Q of the gas, for the collection efficiency of 99.8, that is eta. So what is the question? Corona power is required. So P, corona power is PC. Power is P, corona power is PC. So there is a graph, same like our cycloseparator. Here also there is a graph. Its x-axis will be your corona power ratio. Corona power ratio, that is PC by Q ratio, flow rate. Okay. Then y-axis will be your collection efficiency. So if you know the collection efficiency, you can get the PC by Q value. So what is the collection efficiency they given in the question? 99.8. So if you match the 99.8 with this graph, I will get the x-axis as PC by Q value equal to 330. Okay. I know the Q value. So I will get the corona power. What is the Q value? 9,000 meter cube per minute. So this is given in watt per 1000 feet cube minutes. So I have to convert that into feet cube per minute cube. So if I convert and multiply, feet cube per minute will cancel off, and I will get, see, 330 by 1000 into 3, if I multiply, I'll get everything in watt. I can convert to kilowatt. So 110 kilowatt power, that is the corona power required for electrostatic precipitator to get an efficiency of 99.8% to treat the flow of 9,000 meter cube per minute. Yeah. Okay. Okay. Now we will move with the wet scrubber problems. Yeah. Estimate the collection efficiency of wet scrubber. How we all know, right? There is a tap. There will be some sprayers like our shower. Water will be sprayed. Water will usually fall down with gravity. Air will go up in earth, and then if you pass the air from down to bottom to top with the dust particles, the water droplets from top to bottom will capture the dust particles and dissolve, absorb the particles, impact all the mechanism we have seen, right? Due to Brownian motion, due to inertia, due to impact, the absorption and the adsorption, everything will happen, and the particles will be dissolved in the, not dissolved, captured in the droplets, and the water will be collected at the bottom. That water will go to water treatment plant. Yeah. So this is the principle of wet scrubbers. They are asking the collection efficiency again eta of 5 micrometer dia particle. That is the particle in the air, inlet air, of density 2 gram per centimeter cube, particles density, in a counter current spray tower. It's a spray tower. Or wet scrubber is again a spray tower only. From top it's spraying. Uh, of tower height to 2.5 meter. The gas flow rate is Q is given, and the water flow rate is water will flow from top to bottom. That is Q water flow rate. Air will flow from bottom to top. That is Q air. That is also given. Both are given. The gas velocity 10. The B droplet dia. Dia of the particles are given, the air particles. I mean the dust particles in the air. Dia of the water particles also given in the question. Assume the temperature is 20 degree. Cutting up correction of 1 and flow to be potential. Use the droplet terminal settling velocities. So droplet settling velocity they have given. What's the formula for collection efficiency in wet scrubbers? I have given in the formula sheet. Overall efficiency equal to 1 minus exponential of minus 3 by 2 impact number or efficiency of impact into QL by QG, that is the flow of the liquid, flow of the gas. I mean water flow and the gas flow. Z. What is the Z? Tower height, that is already given for the wet scrubber by dt. Particle falling drop part. This is the drops diameter. We want the particle size diameter also. And then Vt by Vt minus Vg. This is terminal velocity of the, here you can see Vt is droplets terminal velocity. Vg is velocity of the upward gas velocity. Okay. If you know all this thing, only eta I is missing. Other values we know from the question itself. How to find eta I? Eta I can be found from this graph with eta number. Sorry, Ni. That is the impaction number. If I know the impaction number, I can find the eta I, impact efficiency. So, impact number, there is a formula dp square rho p kc vp minus vd by 18 mu g dd. So, all are known. Diameter of the particle we know, density of the particle we know, kc is given, continuous correction factor they have given us 1. vp minus vd we all know already, particle velocity and drop velocity, and 18 into mu g dd. Can I substitute into the question? Yeah. So all known, unknown is beta I. For eta I, the formula is through Ni. Ni formula is given here. So dia of the particle is given. Rho is 2, that is the particle density. Kc is 1. Vp is given. Vd is given. Mu g is given, and dd, the dia of the particle droplet. So that is 800 micrometer. So if I substitute all, I'll get the Ni value. Ni value is 0.439. So that I will get, if it is 439, I will get the impact efficiency eta I. So if I substitute that is 31 as eta I in the overall formula, I will get 79.2 as the collection efficiency of the given spray level of height. Height is also given, right? Is the question. Yeah, 2.5 meter height there. Tower. Yes. Hope you got it. So I'll move on to the next problem with absorption, oxidation, and condensation. So the first question is related to think about this conversion factors. 1 feet is 0.3 meter, 1 feet square is 0.09 meter square. This is a rough calculation you can note down. 1 feet cube is 0.028 meter cube. 1 pound is 0.45 kg. For easy conversion, 1 degree Celsius is 5 by 9 degrees Fahrenheit minus 32. And 1 BTU, British thermal unit, that is a calorific unit, you can take as 1055.06 joules. Yes. So these are also some of the conversion factors you need to remember, and it's basic only. So first question of absorption I am going on. A dry cleaning process exhaust 15,000 SCFM, standard cubic feet per minute. So it's normally FT cube per minute only, but it is standard. Standard is standard temperature and pressure. Actual means actual temperature and pressure. So they have given the exhaust flow rate, because feet cube per minute is a flow Q only. Standard flow rate they have given, air stream containing 680 ppm carbon tetrachloride, that is a pollutant. So that concentration of the pollutant they have given, and determine the saturation capacity. Determine the saturation capacity of the activated carbon, because absorption will be working only with the activated carbon kind of things with the higher surface area. Using the absorption isotherm for CCl or activated carbon, assume that the temperature and the pressure of the exhaust gas are approximately temperature and the pressure they have given, that is the actual. So if you want to convert the standard to actual, you can use this temperature and pressure for your calculation. Okay. So what's the formula for saturation capacity? Can I go with the second page of the formula sheet? So just I will share this formula sheet with you. You can find everything in this one formula sheet. So second question will be, sorry, second page will be your absorption formula. What is the capacity? How to find the capacity of the capacity can be found from this table, sorry, graph with the partial pressure, known partial pressure and the temperature. What is the known partial pressure and temperature given in the question? 140 degree Fahrenheit and 14.7 pressure. So if you go with the same 140, 14.7, 140, 14.7, yeah, PSI. Yeah. So one second, one second. They asked us to find the saturation capacity. What's the formula for saturation capacity here? Absorption capacity is based on the partial pressure. Is this the assignment question this week? How to solve this Bauhaus? I think now only we have solved the Bauhaus problem, right? Yeah, they given the flow, they given the velocity, each bag they have given, so you can find the area of one bag and the area to cloth ratio is there anything is there? No. So they are asking the number of bags required. So Q is given. So from the filter bags formula sheet, the fabric filters. So area to cloth ratio is not given, but Q is given and area to cloth ratio. Okay, area to cloth ratio is missing, but V is given. What can we do with V? Q is 800 meter cube per minute. Okay. Each bag is 23 centimeter wide, 3 meter length. Okay. This question I will solve in a sheet again. Yeah. Let me try to solve. So they have given Q as 800 meter cube per minute. Yes. So I know the area of one bag is surface area of one bag is 3 into it's a square. Okay. 20 centimeter wide and 3 meter length. So it's a square, it's a cuboid bag. So I can take it as 0.2 meter. So 0.2 into 3 will give you surface area into 4. 0.3 into 3 into 4 will be your area of one bag. Because 4 sides are there, right? There is 3 meter height and 0.2 meter wide. All the 4 sides of the bag will contribute. So it will be 4. So 3 into 0.2 into 4 will be your one bag. Okay. And Q is given. So Q by total area, A total we don't know because that will be the A by C ratio. That also not given in the question. Okay. Okay, only Q is known. And V they have given us 4 meter per minute. Okay. So if I know the total area, I can divide it with this. What is it? 12 into 0.2, 2.4. 12 into 0.2, yeah, 2.4. So 2.4 I have to divide with the total area. Total area required, how to find the total area required? I'm going to back sheet for the fabric filters. Pressure drop also not given, right? Okay, they given directly Q and V. That itself enough, right? Right. Sorry. So if I know the Q, check the unit. That's what I said, always unit matters. If Q is meter cube per minute and V is meter per minute, it's simple sum. If you divide, you will get meter square. That is the area. So A equal to Q by V. Simply you can find. That is the total area. What is that? 800 by 4? 200. 200 by 2.4. What is the answer? 83 bags. Is there any option for 83? 83 is not there. Okay. So total area is 200. Area of one bag we need. No? Area of one bag is 3 meter length, 23 centimeter wide. Into 4 only we have to take. Yeah, 4 sides. 200 by 3 into 4. 1 second. 200 by 60 is not the right option. 200 by 2.4. 83 bags. Is there any option here by 95 is there? Okay. Okay, I will check the calculation once again. Q is given as 800 divided by V is 4. So answer is 200 is your total area. Divided by one bag area is divided by one bag area is 0.2 into 3 into 4. Answer is 83. Yep. Cubic velocity of the gas. Filter velocity. Each bag is 20 centimeter wide and 3 meter in length. This is correct. Answer is 83 only. So I think the nearest option 95 you can choose, but okay, okay. They have given the spacings also. Spacing of each bag is 30 meter and the wall is 30 centimeter. If the spacing between each bag is 30 meter and the wall is 30 centimeter. If you take each bag it's 30 meters and the wall is 30 centimeter. Each bag is 30 meter and the wall is 30 centimeter. So here it will be 30 centimeter. And here also it will be 30 centimeter. and each bag will be 30 meter. Another bag like that if it is there. Okay, there is nothing to do with spacing. We know the total. Okay, total this area we know. Okay, we have to subtract the. Okay, got it. I will take one more page. Yes. See, so the flow is happening in total square. The flow is coming, Q is coming, uh, and the V is the velocity. So we know the total area is now 200, right? 800 by 4, that will be 200 meter square. Yeah, the total area is known, and they are saying it will be 3 meter length. So length we don't want anyway. So only the top view, if you see, it will be 0.2 meter with 30-meter spacing, and the next one will be again 0.2, like that. Another 0.3, sorry, 3 meter, sorry, 30 meters, yeah, 30 meter, one box will come. Okay, so one square will be, I mean, for 4 boxes will be, how much area it will take? Center to center, I am saying. So center to center will be here, another 1.2, 0.2, so 30.2 into 30.2, that will be my one square's area. So if you multiply, 900 is coming. Is that 30 centimeter or 30 meter? Can you check the question? If it is 30 centimeter, then it will work out. 30 centimeter means 0.3 meter. Yeah, then I can take 0.5 into 0.5. Then 0.25 will be one box. So 0.25 will be one square. If I take 200 by 0.25, be 800 again. 800 areas I can get. 4 it will be. 0.5, 0.5 be one box. Can you check point 30 meters or 30 centimeter in the question? Because the spacing between bag will not be 30 meter. One bag will be here, and one bag here, one bag here, and one bag here. Totally it will be 0.5 per box. So 0.5 square is the total. Yeah, 0.5 meter square, 0.25 meter square, 200 by will be 800 meter square. There is a mistake with the bag. The length is not working here. Okay, Q. Let me count this. Okay, there is a length of bag. Three meter, 3 meter right, 3 meter length, and 0.2 meter wide. So here will be flowing through the surface area. Surface area of a cuboid will be 0.2 into 3 into 4. 12 into 0.2, 2.4 will be the surface area. Okay, and 200 will be my total area. So the answer will be 200 by 2.4. That is the number of bags. That is the number of bags. Then they're asking the spacing also. I will check with the question once. Is this week's question, assignment question? Yes, they given 30 meter, 800 meter cube, 20 centimeter wide and 3 meter length. If the okay, it's a bar house. Okay, it's a bar house. So we'll go with the ninth PPT. Size we don't know because the cloth ratio we don't know. See the bags stacking. It will not be 30 meter. It will be 0.3 meter or 30 centimeter maybe. So surely it will not be 30 meter. That is only yeah. Okay, I will look into this problem and I will solve and I will post the video maybe within tomorrow again for this short one video I will post, okay, or I will add in the same YouTube video what I am doing now. Okay, you can see that the same question is there. Splitter, tolerance. Okay, what are the questions I have taken? It is not filter box is not there. Okay, let me continue the session. I'll finish and I will solve this and I will post the video again. Okay. Okay, I'm so sorry. My audio is mute. Uh, are you able to hear now? I'm so sorry. I will make another video, small short video for that one question because it will not be 30 meter. You can see this filter bag. It will be surely 0.3 meter. It should be. So I'll look into the question back and I will post the answer again. Yeah. Let me continue the session. So we are working on the adsorption principle and they have given the dry cleaning exhaust, concentration of the carbon tetrachloride and the flow rate in feet cube per minute, that is standard pressure and temperature. And they have given the temperature and pressure, that is the actual temperature and pressure. So that is the ACFM and SCFM, standard feet cube minute and the actual feet cube per minute. So we need to find the saturation capacity. So what is the formula for saturation capacity? So this is the saturation capacity. For finding the saturation capacity from the graph, we need the partial pressure. So if I know the partial pressure, I can equate with the temperature what is given in my condition. Then I can find the capacity by weight. So how to find the partial pressure? So there is a formula P. I have given in the formula sheet also. So you can refer here. Partial pressure equal to pressure into concentration. So I know the temperature 140 Fahrenheit. I know the pressure that's given in the question. Where is the ah. So 140 degree Fahrenheit, pressure is 14.7. That's a standard PSIA. See here. So if you multiply the concentration 680 ppm, ppm is into 10 power minus 6. Okay, so or million parts per million. So 680 per million 10 power 6 also you can have. So 0.0068 into pressure is 14.7 psi. If you directly keep, you will get the partial pressure in psi, and the graph also psi only. So 0.01, if you equate with 140, that is a given temperature, you will get 40 as your capacity. Okay. In the second question of the same absorption, a dry cleaning process of exhaust, the same flow rate, standard flow rate, concentration of the pollutant they have given 680 parts per million, 4-hour cycle it's such. Okay, 4-hour cycle. What is the amount of carbon, that is activated carbon used as absorbent? How much amount of carbon required? So that is 140 and 14.7. So that is the given actual temperature and pressure. So to find the amount of carbon required, I will go to the formula sheet. What are the formulas here? See, the amount of activated carbon at saturation, how much it is required equal to flow rate we know divided by percentage by weight of activated carbon into working capacity. So we want all these values. So flow rate we know. Flow rate QCCL they have given us 15,000. So that is known into that concentration if you take. So this is in feet cube per minute. So 15,000 into the pollutant, that will give you 10.2 standard cubic feet per minute of this pollutant. Then what I want to calculate the amount of activated carbon required. The flow is 980. That is the calculated one where it is. Sorry, 10.2. 10.2 is it standard cubic feet per minute, and the flow rate is 10. Okay, so 10.2, if it is in feet cube per minute, I want to convert that into moles. Then only I can get the carbon's mole, because everything if you convert how much moles required, then it will be easy, because molecular weight if you change, it will change for each pollutant. So I am converting it into same concentration of moles. So 10.2 will be my flow rate for the pollutant CCl, carbon tetrachloride. So for that, if I multiply with that molecular weight, that is 385.4, that is a conversion factor to convert it into feet cube per pounds per mole, then I will get this one. Again, if I multiply 154 lb, that is the molecular weight of carbon tetrachloride, into, if I convert into time per hour, 244 lb of carbon tetrachloride per hour, that will be my flow rate. And I know 4-hour cycle. So 4 of this much will be 980. So that will give you total concentration of the pollutant. Then this much concentration, how much carbon is required? That's the question they are asked. And the carbon, I know the molecular weight is 30 pounds. It's actually 12, and they are using given that the saturation condition, the activated carbon used will be 30 pounds of vapor for every 100 pounds of activated carbon, because they given in the question itself 30% by weight will be the saturation capacity. So 30 pounds for carbon, if you divide it by 30 percentage, that is 30 by 100, you will get 3270 pounds of activated carbon, that is requirement. And they also given the working capacity is 25%. That's why I given all as a single formula. Quantity of or concentration of the pollutant into uh, sorry, divided by 30 will be your percentage by weight into the working capacity, that is 25 percentage. So if you multiply all 30 by 100, 25 by 100, and by concentration I can find from the given concentration, flow rate into concentration of the pollutant into conversion of mole into the hour conversion. If I multiply everything, I will get how much carbon required per for total 4 hour cycles. That is 13,100 pounds of carbon. That is the requirement. So the third question is also again on absorption only. So they given a regenerative carbon, that is a carbon bed that can be again and again regenerated, that has three bed in parallel, each having a gas flow rate of 9,000 standard cubic, that is a Q of gas, and temperature they have given, and the gas pressure also they have given, and the barometric pressure. So there are two pressure, one is gas pressure, another one is barometric pressure. Barometric pressure will be the atmospheric pressure, that's 30.3 mercury terms. And what is the minimum cross-sectional area of the each bed? That's what they are asking. To maintain uh, gas velocity must be maintained below 100 feet per minute. So gas velocity they have given V gas 100 feet per minute. So I am provided with the gas velocity, gas flow rate, gas temperature, gas pressure in two terms. One is water column pressure, another one is barometric. If I add this two, I'll get the total pressure of the gas. So one is in point plus 4 in water column, another one is in mercury. Mercury, if I want to convert into water, what will I do? 13.6 I will multiply. So 30.3 into 13.6 will give you one value that will be in terms of water column. So that if you add with the 4, that will be your total. So I am just multiplying 30.3 into 13.6 and add with 4, 416 in water column will be my total pressure. And what I am asked you to find, minimum cross-sectional area. What is the formula? Go to the formula sheet. So minimum cross-sectional area will be, where is the area formula? Okay, area will be V equal to Q by A. The simple formula I am just converting here. So Q by V will be your area. So if I know the flow rate and the gas velocity, I can easily find it. So I know the gas flow rate, I know the gas flow velocity, I can find the area, right? So what is the gas flow rate? 9,000 into, that is in standard. So if I want in actual, what is the conversion for standard to actual? They are provided with one temperature and pressure. I have to make it by actual temperature and pressure. What is the actual temperature and pressure here? Pressure is 416 in water column. Actually, the temperature is 100. So if it is in degree Fahrenheit and water column, this is the formula. I have given the formula here. So if I want the actual pressure, sorry, actual flow rate, then standard flow rate into temperature 460 Fahrenheit plus actual temperature by 528. These are all empirical formulas into 407 pressure in water column by actual pressure, that is 496. So 416. So if I put all my value actual, here also actual, all are standards. 460 and 528 are standard, 407 is standard. So you will get the gas flow rate, actual gas flow rate. So actual gas flow rate by velocity is given in the question, 100 feet per minute. So if I divide by 100, I'll get 93.4 feet square. So that's my area, actual minimum cross-sectional area. You got it? Then there's some problem related to absorption. So they given compute the minimum liquid flow rate. Again, Q only they are asking. Of a pure water required to remove 90% of sulfates. Sulfates they are absorbing in water. Okay, so 90% removal is required. Gas stream is Q they have given 3000 ACFM or 85 meter cube per minute containing 3% of SO2. So 3% of SO2 is coming in, 90% removal, then what will go out? 0.3% will go, sorry, 0.03% will go out. That is 10% of that. So remaining will be absorbed in the water. the temperature of the pressure, everything was given, and Henry's law constant was given. So absorption, you see the formulas for absorption. See here. So there is a gas in and the gas out, and the water will come from top to bottom, same like wet scrubber. Absorption works on the same principle of wet scrubbers. So gas in, there is a uh, flow and there is a concentration. So what's the concentration? 3%. What is the concentration out? 0.03%. Same, I know the concentration of water coming in and coming out. It's a pure water. So there is zero concentration there, sulfate concentration. And going out, what will be the concentration? I know. And what will be the uh, flow of water? That we don't know, right? So this diagram, if you know, you will get this formula. So for mass balance, Gm in plus Lm inlet equal to Gm out plus Lm out. So that's the flow. And I am assuming mass balance, whatever coming in will go out. So that will be equal Gm into y1 minus y2 will be Lm into x1 minus x2. Final formula you will get as y1 minus y2 equal to yr, the pollutant concentration. Y1 minus y out is 3% minus 0.03% will be Lm by Gm into x1 minus x2. This formula if you take at the Henry's y1 you can calculate by Henry's law into x1. So if you substitute this, everything will be converted into terms of x1. There it is. Yeah. See, 3% is coming in 0.03, 10% of it is going out 0.003, and the flow rate of it I know, and 0% because pure water. So 0 is x2. What is the x1? That's what the question of minimum liquid flow rate. Okay, flow they are asking. LM2 is the required question. So if I know this formula y1 equal to Henry's law into x1 because that is a known factor, and I know the total formula based on mass balance, I will substitute here. Y1 is h into x1, y2 I know 0.03, 0.003, and x1 I can find as Henry's law into that, and x2 is 0. I know x2. X1 is downward, x2 is 0. Okay, and if I get this ratio, flow rate of liquid by flow rate of gas. Flow rate of liquid only they are asking. Flow rate of gas we know 85. So if I divide 38.7 by 85, I'll get the flow rate of gas. Sorry, liquid, that is a water. But if they are asking in meter cube per minute, my result are in what is my result? Sorry, gram moles of water per gram moles of air. So I have to convert it with the moles or molecular weight of the air. Molecular weight of air is you can see here 0.024 meter cube of air will be there in 1 gram per mole. So if I substitute here, I will get 3540 gram mole per air per minute. That will be my GM because 85 I can't directly divide. 85 is in meter cube per minute. This is in this unit. So I am converting in the same unit. So 85 meter cube per minute of air. How much will be gram will be there in that? 3540 gram of moles of air will be there. So if I substitute, divide this with the 85, I'll get 38.7. That's my liquid flow rate. You got it? That you can easily convert again to meter cube per minute. So for dividing, I am taking into moles per hour. Directly you can convert this answer in moles per sorry meter cube per minute, and you can divide with your GM1. You will get LM. So don't get confused with the absorption problem. It's easy mass balance. If you know only this diagram, you will easily get concentration coming in, coming out. That is Y1, Y2. Liquid concentration coming in X2, going out is X1. And flow is GM1. Flow of liquid is LM1, LM2. Okay. Yeah. So again absorption problem only. Calculate the amounts of calcium hydroxide required. Because whenever the pollutant is getting absorbed in the water, it will increase the acidity. So I need some alkalinity. So how much alkalinity is required? That can be provided with calcium hydroxide. So what's the formula? Because HCl I am neutralizing. So equation will be HCl plus CaOH twice will give you Ca plus 2Cl minus 2H2O. That will be your formula. So 2 moles of HCl acid, 1 moles of calcium hydroxide is required. That is the alkalinity requirement. Okay, to get 2 calcium, 2 chlorides, and 2 water. Yes. So they are asking how much calcium hydroxide is required to neutralize HCl absorbed in the gas stream having 50 ppm of HCl. Flow rate is 10,000 SFL. So if you multiply this two, you will get total HCl. So 10,000 into uh, 50 into 10 power minus 6, that is in ppm. So 10 power minus 6 lb moles per 385.4 will be the conversion factor for SCFM into uh, moles per pounds moles per sorry, feet cube per mole. So that you will get finally 98% only will be observed. Not all 50 into 10,000 will be observed. Only 98% is the efficiency. So that if you multiply, you will get the HCl concentration. That HCl concentration will be the total getting absorbed. For that, half of this or 2 HCl will require 1 CaOH twice, right? So if this much HCl is there, how much CaOH is required? By 2. So if you subtract that by 2, here you can see 1 lb requires 2 lb of HCl. So same if it is in lb mole, again 0.00123 will be your molecular weight of calcium hydroxide. You all know calcium hydroxide moles in gram per mole, but here every unit sits in pounds per mole. So just convert into pounds per mole, it will be 0.0123. So just if you multiply and divide by 2, you will get how much moles. Then again multiply with 0.0123, you will get in pounds again. Moles will be converted to pounds per hour. So per hour, this much calcium hydroxide need to be supplied. Okay. Okay. Now I am going with the oxidizers. Let me skip oxidizer as of now because I am going with condensation. There are lots of problems in the assignment related to condensation also. Because the time is running out, it's already 7:30. We are going to see some of the assignment problems also. So condensation, I'm directly going. I have given oxidation formula here. That is simple formula only oxidation. Whatever the gas, exhaust gas coming out, the flue gas flow rate will be equivalent to emission stream flow rate plus natural gas flow rate plus dilution air flow rate. Dilution air will be your nitrogen. Fuel will be your oxygen. Emission will be the product, CO2 and H2O. If you add all these three, whatever the fuel gas you supplied, that will come. So it's a simple mass balance. And residence time will be calculated by chamber volume by volumetric flow rate. That will give you the residence time. How much time the gas is inside in your chamber. Okay. So for condensation, there are lots of problems, but very simple. See, if you want the condensation principle, you know, right? We are freezing the pollutant and we are extracting the pollutant in the form of recovered product. So that's the principle of condensation. If there are a huge concentration of pollutant like particulate matter or any other volatile organic carbon, I want to extract in the material form, I'll freeze it. For that, how much partial pressure if you want to know, formula is 761 minus 0.08 RE. RE will be your removal efficiency. That HAP is hazardous air pollutants. Hazardous air pollutant. Everywhere HAP will come. Hazardous air pollutant equivalence. E is contaminant concentration entering into 10 power minus 6. So if you know that, P partial will be there. Then how much is inlet concentration if you want? Inlet QE will be a maximum flow rate, inlet flow rate, and HAPEM into 10 power minus 6. That will give you the inlet emission. Outlet emission, if you want, HAPOM, that is the outlet emission. If you know the inlet, then you substitute here, you will get the outlet flow. P vapor and PE will be your vapor pressure or partial pressure of your gas and the partial pressure of your system. Then moles of cap condensed, how much condensed air pollutant, hazardous air pollutant, I'll get from inlet minus outlet, they'll give you the condensed HAP concentration. Then H concentration if you want, that is the enthalpy change. H is your enthalpy if you want. HAP concentration into del H, that will be given. Del H is heat of evaporation. CP HAP, average specific heat of the compound. T is temperature exit, temperature of the condensation temperature, everything will be given. And you substitute, you will get all these values. Okay, so just I will move on with the problems. What will be the maximum removal efficiency for toluene? Toluene is a pollutant, hazardous air pollutant that will be removed by condenser. Inlet concentration is 10,000 ppm. Outlet partial pressure is 0.01 mm of mercury. So if you see here, they are asking about the removal efficiency. Efficiency will be inlet concentration minus outlet concentration by inlet concentration into 100. Inlet concentration 10,000 we know. What is the outlet concentration? They are saying 0.015. So 0.015 mm of mercury. So if you multiply with 760 mm of mercury, sorry, divide with the, you will get it ppm. So that ppm you have to subtract with the 10,000 ppm, you will get 99.8 percentage will be your removal efficiency. Okay. Then the eighth question, determine the partial pressure of the HAP. So P, partial pressure of HAP is, they are asking for the condensation process, and determine the condensation temperature. T, condensation. So both formulas were given in the formula sheet. You can refer. P partial equal to 1 minus removal efficiency is 90% given. Half E, exit concentration 13,000 is given in the question. And here also 13,000 in 10 power minus 6. You will get partial pressure of the gas. 1 milligram. If you want in mercury terms, everything will be in your mercury terms because it's 760. So it will be in mmHg. That then temperature of condensation temperature, that will be taken from, where is the formula sheet here? See, there is a graph for condensation. Okay, I'm just going to keep the graph. I will keep the graph here. If you know the partial vapor pressure, partial pressure, then you can get this value 1 by T condensation plus 460. That is in degree Fahrenheit. Okay, degree Fahrenheit. So I know the partial pressure is 1 mm of Hg. So if I go with 1, 2, 3, 4, what is 1, 2, 3, 4? Styrene, toluene. So my pollutant is styrene in this question. Second question is about styrene. So my pollutant is styrene. So I will go to 1. I'll get the 1 by T condensation temperature plus 460. That is 0.02080. So if I cross multiply, I'll get the condensation temperature in degree Fahrenheit. 20 degree Fahrenheit is my condensation temperature. Then all this are based on formulas only. HAP EM, HAP OM, HAP condensation. This is the enthalpy. All formulas are given, and the questions, given data, everything was given here. See, HAP E formula is QE by 392. QE is given as 2000. HAP E is given as 13,000. Substitute. And then HAP OM is QE, HAP E, P vapor by PE, that both are given. PE, P vapor. Then del H, that is your assumption only. Enthalpy of your pollutant, whatever that you can take from chemical engineer's handbook. And for your pollutant, this given question it is 17,450. Usually it will be around 17,500. And they are asking HAP H concentration. Formula is H con equal to HAP con del H plus CP HAP TE minus T con. So this is unknown. H con we already found in a formula above. You substitute, you will get this. H non con. H non con formula again based on QE, HAP EM, CP air, partial pressure of the air is given, and then TE minus T con. Okay. So TE, T con, how to find? That formula also I have given here. T con, T cool, everything is based on this temperature only. T con minus 15. T cool O, if you want, T cool I, if after finding that, add to 25 degree. Everything is in Fahrenheit. Okay. Yes. So again, this four are based on the same formula I have given in the formula sheet. Don't need to remember formula, I guess. This formulas and all will be given in the question. I think not much difficult formulas will be asked in the NPTEL problem. Like Q coolant will be H coolant by CP coolant, T cool O minus T cool I. T cool O, T cool I, temperature cooling in and the out will be found from this formula. Just substitute, you will get. And the theory lecture for this week, it's based on air quality standards. That one reading indicator item alone I will explain now. So if you take AD, I have uploaded in the sheet also. I will show you. So if you go to the reading material, I have also uploaded the already uploaded the National Ambient Air Quality Standard PDF. How to read this PDF? See, they have given a pollutant. So this is the 2009 version. Earlier it was in 2000. Sorry, it's in 90s. Older it was 90s. Now it was in 2009, it was reaffirmed. So first column will be your pollutant. What are the pollutant, target pollutant you are going to measure? Then time weighted average. Some pollutant will be for 24 hours, some pollutant will be for annual. And the zone. Earlier it was industrial, residential, rural, and ecologically sensitive. Now all the things were clubbed into residential, industrial, rural, and the one column only for sensitive, ecologically sensitive area. And method of measurement also given in this 2019 rules and regulation. So if I measure particulate matter is 2.510. Earlier it was only particulate matter. Ozone was not there in the earlier thing. And now they have added new pollutant like benzene, benzopyrene, arsenic, nickel. These are all new pollutant added in the NOx standards, National Ambient Air Quality Standard. That's the NOx standard, 2019 standards. Okay. So some pollutant need to be measured only with 8 hours or 1 hour standards. Some pollutant need to be annual and 24 hours requirement is there because ozone will be easily destructed. So it should be taken in a very low time and it is very chronic impact like immediately it will give impact. Got it? Okay. So this is first column will be your indicator pollutant. Second column will be your primary or secondary pollutant. Third column will be your average in time 8 hours, 1 hours, or 24 hours or annual level. So if I want particulate matter, if it is exceeding or carbon monoxide, if it is exceeding 35 ppm, then it's not good for health. That's the maximum limit prescribed in the NOx standards. Then form or any measurement techniques. Got it? So other lecture is about air pollution legislation and regulations. You can see lots of regulations and acts from 1900 to 2022. I can give an overview like Bengal Smoke Nuisance Act, Bombay Smoke Act, Motor Vehicle Act, Factories Act, Inflammation Substance Act, Mine Act, Atomic Energy Act, and Gujarat Smoke Nuisance Act. These are all act and regulation related to air pollution and control. And 1981 onwards, the major rules are coming up, like Air Pollution Prevention Act, that is the first of its kind, Air Pollution Prevention Act, the Air Act, that is 1981. 1986, your EP Act, that is Example Production, that is the Umbrella Act. And 2010, the National Green Tribunal Act came, and early 1995 itself, the National Environmental Tribunal Act came, that paved way for National Green Tribunal, that is a separate court to deal with the environmental related cases. And 2022, there was a draft notification for e-vehicles in the National Capital Region. So just theory only you can go through what are the aims and what they did in each scheme or each act. Mostly they prescribed standards and they framed rules and they kept fines and if any violation is there, what is the fine or what is the steps need to be taken. That's what taken in all these acts. Okay. And they reduce some of the ozone depletion substances reduction, e-vehicle transformation, then shifting the power from central pollution to state pollution control boards. And state pollution control board have their own um, uh, rights to change the values. If the CPCB is prescribing 20 is the maximum limit, I can say 10 is the maximum limit. You should not go above 10. Okay, so that freedom is there with the state pollution control board. Each like Tamil Nadu, they have a separate air quality standards. But that will not be more than the CPCB values, but that will be less than the central pollution control board values. We can have. Okay, yeah. And the policies, like these are all the timelines for each policies. I will show once. Yeah. So these are all the major policies like National Air Quality Monitoring Program, NOx standards, and AQI standards that we have already discussed about the color codings to get the poor, very poor, and the medium level of air quality, and then high level task force, compression action plan, and graded response action plan, National Clean Air Program. These are all the program or the government initiatives related to air pollution. Okay. Yeah. So I'll go with this older assignment problem once. Can you try to solve this? First question is related to calculate the minimum size of the particle that will be removed with a 100% efficiency. So they are asking eta equal to 100% they given. They are asking minimum size of the particle. So dia of the particle they are asking. So we know the formula, power 1 by 2 formula that we know. So just fit all the values from here. So just find the value. What is the answer? Can you just, I will show the formula. 18 V H mu by L into G rho P by rho. Particles density, density of the air, you can take 1 or negligible. Okay. So all the values are given: V, height, length, viscosity of the air, density of the particle. So all are known. So you just substitute and you will get the value. Okay. 59.2 micrometer is your maximum diameter, sorry, minimum diameter size of the particle that will be settled in the settling chamber. Then the second question is related to electrostatic precipitator, in which the collection plate area is given. Area of the collection plate 120 meter square, and the collection efficiency is given eta. Omega is given 0.25. We know the formula for efficiency: 1 minus e power minus omega a by q. Yes, omega a by q. So if you substitute all the values, you will get q, 4 meter per second. Thus efficiency is 98.94%, 0.9994. Okay. Yeah, just find gravity settling chamber. Now only I have said like this formula you can use and you can easily find the minimum size of the particle. We want me to solve this. I think okay. Let me try. So 18 into, what is the V? Horizontal velocity is 1. Okay. H 2 meter. Okay. Mu viscosity is 2.1 into 10 power minus 5. 2.1 divided by 10 power 5. Okay. So total divided by length 10 meter divided by 9.81 divided by specific particle 1500. I can take as 1500 itself. I will neglect this. So if you take root, the answer is 7.16. The answer is in meters. Sorry. Which unit it will be? Meter, everything is in meter, right? So it will be, answer will be in meter. So into 10 power minus 5 meter. If I take 71.6, 10 power minus 6. So answer is micrometer. Answer is 7. For this question, answer will be 71.6 micrometer. Yeah, correct only. What is the problem here? 71.6 is correct in 10 power minus 6. Hello. So the option is not there for 71.68. Check the answer sheet. Let me check. It's there, right? 71.68. You can click this, no issue. Yeah. Okay. I'll move on. So they are saying it's an electrostatic precipitator. Efficiency is given. So we can easily find, right? Q we can easily find. Yeah. Third question. What is the maximum toluene removal efficiency in a refrigerator type condenser? So it's a condenser problem. Inlet concentration is given. Outlet partial pressure for toluene is 0.015. So what's the maximum removal efficiency? So if I know, again the same formula only, simple formula, eta equal to inlet concentration minus outlet concentration by inlet concentration into 100. So inlet concentration is given as 8000 ppm. Outlet concentration is in kg. So 760 kg. If I subtract, that will be my ppm, parts per million. So how much it is? Can you calculate? Let me give the answer is there. See, 0.015 by 760 into 10 power 6 will be my ppm. So again, I already have a ppm of inlet concentration. So 10,000 minus 8,000 or 10,000? 8,000. So here is a mistake. 8,000. So 8,000 minus 19.7 by 8,000 into 100. 99.75 efficiency is the condensing efficiency. You got it? Yes. So fourth question is calculate the amount of calcium hydroxide needed to neutralize the HCl. So what is the equation? 2 HCl will react with the 1 calcium hydroxide and it will produce CO2 plus H2O, right? So you want a neutralization. So HCl is in water. I am adding CaOH twice to neutralize the water. So they are asking amount of calcium hydroxide. For neutralizing, absorbed gas stream of 30 ppm HCl, 15,000 SA. So flow rate is known, concentration is known, efficiency is known 0.98. If I multiply everything, I will get the HCl concentration. Then multiply with the calcium hydroxide's mole, I will get how much LB per hour. So 15,000 is my standard feet cube per minute, right? So how to convert it into LB? That is the value 30. Where is the value? 30 into 10 power minus 6 is my moles per HCl, and 385.4 will be my conversion factor to moles. So if I multiply 15,000 by 385.4 into 30.10 power minus 6 into 98%, I will get the HCl concentration. Then because 30 will be my concentration of HCl, then half of this will be converted into calcium hydroxide, because sorry, half of them will be required for, required calcium hydroxide. See, out of this value, half of this, I am getting this moles, this much moles of calcium hydroxide. Again, I have to convert it into uh, pound per minute. How to convert? 74 will be my molecular weight in pound. So what calcium will be? Calcium will be how much? 40. O will be 16 into 2. And H will be 2 again, because OH twice. So 40 plus O will be 16, 16, 32 plus 2. So 40, 72, 74. 74 is gram per mole. But here everything is in pounds. So how to convert gram to pound? It is a conversion. Gram to pound. So if I fit what is a gram, I got 40 plus 32 plus 2, 74. If I put 74 here, 0.163. Is that the answer? Okay, 74 directly it's coming here. 74 LB per LB mole. Okay, pounds mole. So 0.000572 is my moles into 1 mole will be 74 grams. Then if you multiply, you will get 0.0423 LB per minute. That will be 2.73 LB per hour. Okay. Then this will be theory questions again. Which of the following pollutant was added to the revised NAQ of India in 2019? The 90 standards was not having the ozone, and particulate matter was only 1. Here, particulate matter 10 is there, particulate matter 2.5 is also there. So, ozone is a newly added one. Okay, along with that, many things were added: benzene, benzoypyrone, arsenic. These are also added newly. Okay, in this option, ozone is a newly added. See, ozone, benzene, benzopyrene, arsenic, nickel, these are all newly added. From 1994 to 2009. Then, according to air quality guidelines of WHO 2021, sulfate concentration has increased from 20 microgram per meter cube to sulfate concentration. Earlier they kept as 20 is the maximum limit. Then they have increased the sulfate concentration in the WHO guidelines, WHO guidelines, not Indian guidelines. So the value is 40. See here, 2005 to 2021,
air quality guidelines, they have changed from 20 to 40. So they increased the standard. Some pollutant they have reduced. See, particulate matter and all 10 to 5 they have reduced. But sulfur dioxide they have increased based on the health impacts. According to Ringelmann chart method, a visual assessment method for smoke emission, if the Ringelmann number is 4. What is Ringelmann chart? It's an equipment used to measure the particulate matter in the air. So based on the opacity. So they have a, sorry. So they have a sheet kind of thing. So all the particulate matter will get deposited and the sheet will become black. So if it is light particulate matter, then some transparency will be there. If it is fully packed with the particulate matter, then there won't be any gap. So if the like given a number, you can see here, 0 is clean without any particulate matter, 20 is slightly added, 40 is fully added. It's like a filter bag. After coffee filter, you'll see the dark color. So you can directly go and measure the particulate matter as smoke in the industries with this Ringelmann chart. If it is coded as 4, 80% opacity, 20% only transparent. So they are asking if the Ringelmann number is 4, it represents 80% opacity, barely transparent smoke. Okay. Which of the following act serve as an umbrella act? So as I mentioned, 1981, there was a Air Act. 1986, the EPA Act. EPA Act covers all water, air, solid waste, everything. So Environmental Protection Act will be the umbrella act, which covers all the earlier act. 1974 there was a Water Act. 1981 there was a Air Act. So all was combined with the Environmental Protection Act. 1986 will be by umbrella act. Okay. See, 1986 EPA. This acts as a umbrella act for many other rules. Even vehicle act also coming under this because this catalytic converter we have seen in the last indoor air quality from the vehicles or a point source or a moving source how to convert. We added the catalytic converter to the vehicles, right? That also coming under this umbrella act only. They only mandated to use the catalytic converter in the metropolitan cities in all the vehicles. Okay. So air quality index I have mentioned AQI values in a range they have given 0 to 50, 50 to 51 to 100, 101 to 200. What is the color code? Green, red, yellow, and what is the nature? So you can see here. So 0 to 50 good, 51 to 100 satisfactory, 101 to 200 moderate. So they are asking the question if it is 384, easy layman or any public can understand with this chart. So if you see newspaper every day, they will give one value AQI based on all the pollutant PM, SO2, all the criteria pollutant will come. Based on that, they will give the AQI standard. If it is 384, it's very poor. You should not come out. If it is satisfactory, you can roam around. So that's what the air quality index mentions. Okay. So, which of the following plan aim to achieve national fuel security by promoting hybrid and electric vehicle in the country? So, you can see here and you can say national electric mobility mission is related to e-vehicles. So, lots of other air quality regulations are also mandating the e-vehicles, but here the plan aims to achieve national fuel security by promoting the hybrid and electric vehicle in the country. It's purely given by National Electric Mobility Mission Plan. You can see here NEMMP 2020. It was launched in 2020 and aims to achieve national fuel security by promoting hybrid and electric vehicle. Okay. So today I couldn't be able to take the theory part. Only I have done with this problematic portion. If you have any doubt, you can pick me in the question and answer. I will ready to answer in that also. The question what you have asked, I will solve. And which problem? Susmita Bearable. Which problem? Okay, you have posted a problem. Sorry, I missed that. I will try to solve that also. So it's not in the today's assignment, right? If it is there, I should not solve. A cyclone, yeah, it's there. I'm sorry, but maybe for this question alone, I will solve. Please don't ask the other question because it's in the assignment. I should not solve. Okay, what is the question? Yeah, a cyclone has a inlet with. So you all know cyclone separator will be like this. So there will be a inlet and there will be a outlet. So gas will come here and it will circle and the particle will settle here. The lighter air will go, clean air will go out. Okay. So this entry width plays a major role. So they are saying entry width will be 20 centimeter, 0.2 meter. Okay. Number of turns n equal to 5. It's taking. Gas temperature 350 Kelvin. Okay. Velocity, inlet velocity V 10 meter per second. Okay. Average particle density given. What is the cut diameter? So cut dia is dc. That is 50% cut dia. So the formula whole 1 by 2 that will come along with the 1 by 2 because 50% will be your cut dia. Okay. The viscosity of the air is also given. What is the formula for dc? Can I go to my formula sheet? So in the first page itself, I have given for a cyclonic separator. This is the formula. 9 into so I will directly solve with this formula sheet. Take the calculator. 9 into mu viscosity of the air is 0.0748 into the B is your inlet width that they are given as 0.2 or 20 centimeter. Okay, divided by 2 divided by pi 3.14 divided by V velocity is 10 meter per second. Okay, divided by number of turns 5 turns it's taking. Okay, 5 sorry 53 5 turns into divided by rho p minus rho. Uh, Density of the particle is 1500 kg per meter cube. So 1500 I am taking. It's 1.5 gram per centimeter cube. So 1500 kg per meter cube. Everything I am taking in meter terms. Rho I am assuming as 1. So 1500 or 1499 anything you can keep. The root of this value will be. So answer is micrometer. So 1, 2, 3, 4, 5, 6. Wait a second. Where is the mistake? 9 into mu is viscosity of the air 0.0748 kg meter cube power. Okay. Into with this 0.2 divided by 2 divided by 3.14 divided by 10 divided by nt is 5 divided by 1500 particle density. The root of this value. Okay, this is the answer. So answer is they are asking why is this 534 or 10 power minus 5. Kelvin. So Kelvin is not having any value here. Cyclo separator. Okay, sorry, it's not 1500. It should be in gram per cc. They given us gram. Okay, if everything in centimeter gram per cc, I am substituting in 1.5 gram per cc. Right? What is the conversion value? Gram per cc to kg per meter cube. It's 1000. So 1.5 in a 1500. Correct only. I'll do again. So 9 into mu use kg meter per hour. Okay, this is the problem here. 0.078 is in hour. I have to convert it into seconds. How to convert? Seconds means 3600. 0.0748 divided by 3600. So this is your actual viscosity. Okay. So this viscosity should be multiplied with the 9 into 0.2 divided by 2 divided by 3.14 divided by 10 divided by nt is 5 divided by 1500. Okay, if you take root, now it is 26. The answer is there. Oh, let me write and solve in the paper. 9 into mu is
0.0748 divided by 3600 should be a second into B is 0.2. Am I missing anything? Just check. Into 2 into 3.14 into V 10 meter per second into NT is 5 into 1500 root of. Okay. Just 9 into 0.0748 divided by 3600 into 0.2 divided by 2 divided by 3.14 divided by 10 divided by 5 divided by 1500 root 8.33 micrometer is the answer. It's correct. 8.33. Yeah, correct, ma'am. Mega ma'am is correct actually. 8.33 is correct. Yes, correct. 3600 is correct. Okay. Hope you got it. Yeah. So please be very careful on the unit. If it is in meter, everything should be in meter. If it is centimeter, convert it into 0.2 meter. And here it's hour because velocity is in 10 meter per second. So your viscosity also should be kg meter per second. Sorry, kg per meter second. Got it? Okay. Answer for me it's around 8.9. Sorry, 89, 8.9, but 8.33 is fine. Micrometer. Okay. Yeah. Answer is 8.33. Thank you. So let me end the meet. If you have any doubt in the problem, please ask. I'll be here to solve. That question alone I'll redo regarding the filter bags. Okay. Thank you so much for joining. If you don't have any doubt, you can leave the meet. Yeah. I think most of the question we have solved here. So thank you so much for joining. Thank you all. Okay. So if you don't have any question, I will end the meet. So it's 8.33 here. And this migration velocity is easy only with omega formula, eta equal to 1 minus omega formula. And this is electrostatic precipitator, again collection efficiency, same formula, very easy. And gravity settling chamber, this we have solved now, right? Yeah, with 100% efficiency, it's easy. Okay, thank you all. I'll close the meet.